This is SpaceTime, Series 28, Episode 6, for broadcast on the 13th of January 2025. Coming up on SpaceTime, how the Pluto Charon dwarf planet binary system was formed. BepiColombo's spacecraft swoops low over the planet Mercury for the last time. And taking a look at the year ahead in astronomy. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
A new study suggested the formation of the Pluto Charon dwarf planet binary system may well parallel that of the Earth-Moon system. The findings, reported in the journal Nature Geoscience, points out that both systems include a secondary body that's actually a large fraction of the size of the primary body. And that's unlike other moons in our solar system, which are always just tiny fractions of the mass of their host planets. The study's lead author, Adine Denton from the University of Arizona, says the Earth-Moon system was created when a Mars-sized planet hit the early proto-Earth, causing both bodies to melt into a magma ocean, and that eventually coalesced to form the planet Earth, with debris ejecta flying into orbit around the newly created planet by the impact, eventually accreting to form the Moon sometime later. Denton says this same scenario could also have happened for the Pluto system, and it supports observations of Pluto's active geology and suspected subsurface ocean, despite its location at the frozen edge of the solar system. Back in 2005, scientists performed simulations showing that the Pluto-Charon binary system could have originated through a giant collision. The problem is those were very simplified early models, and they treated the colliding material pretty much as strengthless fluids. In the last 5 years, advancements in impact formation models have included material strength properties, and integrating this information into the simulations results in Pluto behaving a lot more like a rocky core covered in ice, which changes the overall outcome quite significantly. Denton says in previous models, when Proto-Charon hit Proto-Pluto, you end up with massive shearing effects of fluids, looking a lot like two blobs in a lava lamp bending and swirling around each other. But by adding structural strength properties, it allows friction to distribute impact momentum, leading to a more kiss and capture regime. When Pluto and Charon collide under this new model, they stick together, looking a lot like a snowman, and they rotate for a while as a single body, until Pluto eventually pushes Charon out into a stable orbit. Denton says that most cosmic collisions are hit-and-run impacts, where the impactor hits the planet but keeps on going. Or alternatively, the impactor hits a planet and they merge. That's called a Grayson merge. But she says for the Pluto-Charon system we have a new paradigm, where the two bodies hit and stick together but do not merge because they're behaving like rock and ice. Pluto and Charon likely exchanged some material between each other, but didn't lose an awful lot of their material. Pluto is bigger and started up and also ended with much more rock than ice. On the other hand, Charon's a lot smaller and ended up with about a 50-50 split between rock and ice. The two celestial bodies maintained their structural integrity and eventually separated, likely preserving the ancient structures of both bodies which they initially had when they formed in the Kuiper Belt, the icy ring of frozen worlds, debris and comets which circle the Sun beyond the orbit of Neptune. This means the internal structures of both Pluto and Charon should be quite ancient. Now, this new model tells us how the impact may have happened, but not when, which is significant, especially as Pluto is thought to be geologically active and may have a liquid ocean under its icy surface. See, even if Pluto starts out really cold, and that makes more sense from a solar system evolution perspective, the giant impact and subsequent gravitational tidal forces following separation would result in internal heating and consequently the formation of an ocean later. And that has some pretty big implications for the Kuiper Belt as a whole. That's because 8 of the 10 largest Kuiper Belt objects are very similar, from what we can tell, to Pluto and Charon. It's a fascinating prospect. This is SpaceTime. Still to come, the BepiColombo's spacecraft swoops low over the planet Mercury for the last time, and we take a look at the year ahead in astronomy. All that and more coming up on SpaceTime. The BepiColombo's spacecraft's just taken a close flyby of Mercury, swooping down to within 295 kilometres of the sun-scorched planet's grey crater-covered surface. The pass on January the 8th was the sixth and final gravity assist manoeuvre needed to steer the joint European Space Agency and Japan Aerospace Exploration Agency mission into its Mercury orbit insertion trajectory. The spacecraft will enter orbit around the planet nearest the Sun late next year. During this final flyby, BepiColombo flew over Mercury's North Pole, providing scientists with stunning close-up images of the vast sunlit northern plains and what could be the icy floors of deep craters which are in permanent shadow. The probe made its final approach swooping above the planet's dark night side. Around 7 minutes later, it passed directly over the Mercurian North Pole before getting a clear view of the planet's sun-baked north. The flyby marked the last time the mission's MCAMs get their close-up views of Mercury. That's because they're attached to the spacecraft's cruise module, which will soon be jettisoned, allowing the mission's two orbiters, ESA's Mercury Planetary Orbiter and JAXA's Mercury Magnetospheric Orbiter, to separate and move on into their own individual orbits. BepiColombo was launched aboard an Ariane 5 rocket on October the 20th, 2018, from the European Space Agency's Kourou spaceport in French Guiana. The spacecraft consists of 4 sections that will detach at specific points along the mission's journey. JAXA's Mercury Magnetospheric Orbiter's main science goals are to provide a detailed study of the magnetic environment of Mercury, the interaction of the solar wind with the planet, and the diverse chemical species present in the exosphere, the planet's extremely tenuous atmosphere. On the other hand, ESA's Mercury Planetary Orbiter will focus more on the planet's surface and composition, and together with the Mercury Magnetospheric Orbiter will help piece together a full picture of the interaction of the solar wind on the planet's environment. Together, they'll watch how this interaction at the surface feeds back into what's observed from the exosphere and how that varies both in time and location, something that can only be achieved using 2 spacecraft in such complementary orbits. A third section, the Mercury Transfer Module, is located at the base of the stack, and it supplies the power and support systems for the 2 orbiters, as well as propulsion during the cruise phase of the mission. It also protects the orbiters from the extreme temperatures they get being so close to Mercury and the Sun. There's also a magnetospheric orbiter sun shield and interface structure. It's fitted between the 2 orbiters and provides additional protection for the Mercury Magnetospheric Orbiter before it enters orbit. BepiColombo undertook a total of 9 gravity assist manoeuvres during its 7-year journey to reach Mercury in order not to get overwhelmed by the Sun's enormous gravitational field. As well as the 6 Mercury flybys, there are also 2 flybys around Venus and 1 around the Earth. These flybys utilise the gravitational pull of the planets to help alter the speed and direction of the spacecraft, and together with the spacecraft's solar electric propulsion system, help the probe steer into Mercury orbit against the strong gravitational pull of the Sun. When BepiColombo finally achieves Mercury orbit insertion in November 2026, it'll endure temperatures in excess of 350 degrees Celsius, gathering data during what's an initial 1-year nominal mission, with a possible 1-year extension. Scientists want to understand how planets can form and evolve so close to their host stars. BepiColombo, therefore, will study the planet's interior structure, its composition, and the characteristics and origin of its internal magnetic field, all in the hope of finding out why Mercury has such a huge core in relation to its mantle. They also want to understand surface processes such as cratering, tectonics, polar deposits, and volcanism. And they also want to determine whether the planet really is shrinking as it cools. Another key area of exploration will be a better understanding of the characteristic structure, composition, origins and dynamics of Mercury's exosphere and magnetosphere. And finally, the mission will also allow scientists to test Einstein's theory of general relativity by making the most precise measurements yet of the spacecraft's orbit and position. This is SpaceTime. Still to come, we take a look at the year ahead in astronomy, and later in the science report, a new study shows that people who drink coffee in the mornings have a far lower risk of dying from any cause. All that and more still to come on SpaceTime. Well, 2025 hopes to be another big year in astronomy and space sciences, with the Sun's 11-year solar cycle destined to reach its peak at solar max. That's assuming it hasn't already happened. There's a rare edge-on view of Saturn's spectacular rings happening in March. That's something that only happens once every 15 Earth years. The comet G3 Atlas could flare up as it swoops around the Sun this month. That could make it one of the brightest objects in the sky. There'll be 2 lunar eclipses for the year, one in March, another in September. There'll also be lunar occultations of the stars Spica, Regulus and Antares, and the Pleiades open star cluster Messier 45. With the details of these and more, we're joined by the author of the 2025 Australasian Sky Guide, astronomer Dr. Nick Lom.
Mid-January will be a very interesting time to look at the night sky. In the northern sky, we have a whole range of bright planets. In fact, all the naked eye planets, apart from Mercury, can be seen as we move from the west to the north and then towards the east. We have in the western sky, we have Venus just above it, and towards the north we have Saturn, and its rings are very much tilted, so we see them at a very shallow angle. And in the north we can see the bright planet Jupiter, and it's near the bright star Aldebaran, bright reddish star Aldebaran, which is in the constellation of Taurus, the bull. Above them, we have the constellation of Orion, which is a favourite constellation in the Australian summer sky. Again, it's worthwhile to be familiar with Orion because it can be used as a signpost and extend various imaginary lines either towards east or west, and we can find different interesting objects in the night sky. In the north, we have Jupiter and Orion, Aldebaran, and then in the northeast, we have the planet Mars, and that's the reddish planet.
It's in opposition. Yeah.
It's in opposition this year. Unfortunately, it's not a favourable opposition. It's a time really worthwhile to look at the sky, and it's all happening in the evenings after dark, so you don't have to get up early to see them. Unfortunately, it's not the most favourable opposition of Mars because Mars has a fairly oval-shaped path around the Sun, and this time at the opposition, when it's on the opposite side of the Sun to the Earth, it's at its most distant spot, or one of its most distant spots in its orbit. Oppositions take place every 2 years or so, but there's not going to be a favourable opposition until 2033. So it's quite a long time to wait before we get a favourable opposition of Mars when it is starting to be at its close point.
Probably a good time to do a manned mission to Mars.
All missions to Mars, manned or otherwise, so far there hasn't been a manned mission, take place as opposition, sort of being launched a few months before opposition, and so as to timing it to reach Mars at opposition when it's at a close point to Earth, and so it saves a lot of fuel and time to get there.
There are 2 big highlights in March. One is the eclipse of the moon, and the other is crossing the rings of Saturn.
Eclipse of the moon. Now, it is a total eclipse. However, from Australia, we only get a glimpse of the ending of the eclipse, and that's only for people on the eastern coastline. So for people in, say, in Sydney, they have half an hour after moonrise that they can see the eclipse before it ends. People in Brisbane, 43 minutes before the eclipse ends. So you might get a little bit of red on the moon, and that will be interesting to see as it rises, but it is near the end of the eclipse. People from New Zealand can see almost all the eclipse.
The other big event, of course, is the crossing of the rings of Saturn. It seems like that just happened the other day. It was 15 years ago. Wow.
That's right, because Saturn takes 29 years to go around the Sun, and twice in its orbit and its path around the Sun, the Earth crosses the ring plane of Saturn. Saturn's rings, of course, look extremely spectacular in a small telescope. It's a favourite thing to look at, and it's exciting for anybody, whether they've seen it before or not. But in March of this year, the rings will disappear as we go through the ring plane. Unfortunately, on the day that it actually happens, which is the 24th of March, we cannot see Saturn. It's too close to the Sun. But we'll be able to see it just a few days later in the early morning. By the end of the month, we'll be able to see Saturn as it rises. And if you look at it through a small telescope, you'll see that the rings are at a very shallow angle. And for those people who obviously don't want to get up early in the morning, they can see Saturn from now until mid-February. You can see Saturn, and we can see the rings at this very shallow angle. I should say that you do need a small telescope to be able to see Saturn. But those who do not have a small telescope, then they should contact their local astronomy group. They often have viewing sessions, or go to a place like public observatory, like Sydney Observatory. Amateur groups could be the Astronomy Society of Victoria. They have viewings at Melbourne Observatory. Brisbane Astronomy Society has viewings. So everybody has a chance to look through a telescope, and it is worthwhile to look at Saturn.
Now, the planets align nicely in April.
There's a very nice alignment of the planets, or grouping of the planets, in early April, first half of April. You need to get up early to be able to see it, but Mercury, Venus and Saturn form a nice bunch, and they change as the days go on. In early April, they form different patterns, triangles and different configurations, which will be easy to pick up if you do watch them continuously.
In May, there's the Eta Aquarids meteor shower.
That's right. This year it's quite favourable. Now, Eta Aquarid meteor shower is connected with Halley's Comet. As Halley's Comet moves around the Sun, taking 76 years, it throws up dust, and that dust spreads around its orbit, or it's passed around the Sun. And every year in early May, we bump into that stream of dust, and as the dust particles hit the Earth's atmosphere, they burn up, they're leaving streaks of light that are meteors. In the past, people used to refer to them as falling stars. This year, it's a fairly favourable meteor shower, or favourable opportunity to see the shower, because there's no bright moon in the sky. So the moon, that will not hide the faintest meteors by brightening the sky. But that said, it is important to try and find it as dark a spot as possible. See them, basically they can be all over the sky, but the point from which they seem to originate is near the constellation of Gemini, which is also near constellation of Orion.
Now, speaking of constellations, the Southern Cross is well positioned during the month of June.
That's right. Southern Cross is, for some people in Australia, for most people in the southern parts of the country, it's always above the horizon. So what's referred to as the circumpolar constellation. However, it is very hard to see early in the year, January, February, because it's very low down in the sky. So if any trees or houses would block it from our view. I remember once being at the Opera House and hearing foreign tourists wanting to see the Southern Cross in January, but there was no chance of seeing it then, certainly not from the middle of Sydney. In June, it's a much higher place. It's high up in the sky in the early evenings, and then of course it's a lovely object to look at, and people should be familiar with it, because then you can use it to find other objects in the night sky. You can extend various lines from the stars of the Southern Cross and find other stars. For example, kilometres can be reached by projecting an imaginary line from two of the stars of the Southern Cross. Also, it of course tells you if you're lost in the bush, tells you where south by extending a line from the Southern Cross downwards 4.5 times the width of the Southern Cross. You reach a point about which all the stars in the sky revolve, and below that is south. So it's always useful to be able to notice it. And of course it's easy to find because the two pointer stars, Alpha and Beta Centauri, they point towards the cross.
Now, moving to August, and we were talking about the planets earlier. We go back to the planets, Venus and Jupiter, the two brightest planets in the night sky, and they're very close together.
That's right. That's a great sight when you have two planets close together, especially the two brightest ones. Venus is the brightest object in the night sky, apart from the moon, and Jupiter is the second brightest after Venus, or the third brightest after the moon and Venus in the night sky, and that's really the two of them close together and separate. They're only separated by 2 moon widths, or twice the width of the full moon. So they're very close together. That's 1 degree in the sky.
Also in August, it's a great time to have a look at Sagittarius. And when you look at the constellation Sagittarius, you are, of course, looking towards the very centre of our galaxy.
Sagittarius is a very important constellation to Australian astronomers, because they do spend a lot of time studying the region of the centre part of our galaxy. Of course, you can't see the centre of our galaxy very well because there is just too much gas and dust in the way. So not in ordinary light, but with radio telescopes, you can look right towards the centre. And what is the centre of the Milky Way? What's referred to as Sagittarius A star, which is where the central black hole, the mass of 4 million times the mass of our Sun, lurks there in the center of the galaxy, as I said, called Sagittarius A star, and it can be observed using radio telescopes. Sagittarius is a constellation also known as the teapot, and this is because if you sort of join up the stars of Sagittarius, or the bright stars of Sagittarius, then it looks like a teapot with a handle. Once you see that and you sort of pointed out to you, I think it's impossible not to see it as a teapot. So it's a very nice constellation to observe either with the naked eye or through giant radio telescopes.
Now, we were talking earlier about the total eclipse of the moon in March. There's another one in September.
That's right, and this is much better for us in Australia because it's visible through the whole country. The whole country is a total eclipse, and that's happening on the early morning of Monday, 8th of September. A total eclipse of the moon occurs when the moon moves into the Earth's shadow. And you'd imagine that if it's in the Earth's shadow, it will be completely dark. But in fact, it takes on a red or coppery colour. Often in the media, it's referred to as a blood moon. But I really hate that expression because that sort of sounds terribly sinister, and it's not. It's just a very spectacular event worthwhile to watch. The reason it turns red is because sunlight is bent by the Earth's atmosphere onto the moon. And as the sunlight is bent, it goes through the regions of the Earth where there is either sunrise or sunset. And for the same reason that sunrises and sunsets are red with the blue light scattered away, the same reason red light reaches the moon and we see it as a red moon. Exactly how red it becomes, we don't really know in advance. It depends on the state of Earth's atmosphere. If there's been a volcanic explosion in the weeks or months beforehand, then there's a lot of dust in the Earth's atmosphere, and that makes the moon much darker and less likely to appear red.
We were talking about the Eta Aquarids meteor shower earlier. Towards the end of the year, we have the Geminids meteor shower, which are especially good this year.
The Gemini can be a very spectacular meteor shower, and this year we're fortunate because there's no moon or bright moon in the sky, and we can see the fainter meteors. But again, as with the Eta Aquarids, the darker the sky you can find to observe them, the better. They occur in the early morning. They're unusual meteor shower because the Geminids are associated with a rocky asteroid called Phaeton, and that is not a comet. Most meteor showers are associated with comets, but for some reason, this one, the Geminids, are associated with this rocky asteroid.
It's often referred to as a rock comet, isn't it?
That's correct. That's right. So to see the shower looking towards the North Seas in the early morning, they appear to come from the constellation of Gemini. They can appear all over the sky, but you can trace them back towards the constellation of Gemini.
Now, of course, everything you've been talking about here is located in the 2025 edition of the Australasian Sky Guide, which we use as a source of information here at SpaceTime on our monthly Skywatch programs. And the new edition has just been released. Tell me about it.
It's a 30th edition of the Sky Guide, so it's been going for quite a number of years. This year is a very spectacular cover. It's a photograph of an aurora seen from the Grampians National Park. And of course, lately we've been having lots of auroras because the sun is very active. We're near the sun is near it.
Very lucky. You see aurora more frequently than we do here in Sydney, but we actually got to see one in Sydney last week, so that was pretty exciting.
It is very spectacular. It's a magnificent shot, a magnificent photograph of an aurora, and the sun is near its maximum. It might have already reached it sometime in 2024. The solar maximum is something that we can't really know that it's happening until after it has happened, but it did seem to have a bit of a peak in the middle of 2024. The Sky Guide always aims to give people all the basic information they need to be familiar with the night sky. There are maps. These are recently redrawn.
What's the easiest way to get the Sky Guide?
Sky Guide is available in all good bookshops. It's available online, and of course you can buy it directly from Powerhouse Museum, online from Powerhouse Museum, or from New South Publishing, which jointly publishes the Australasian Sky Guide with Powerhouse Publishing.
That's Dr. Nick Lomb, Curator of Astronomy with the Powerhouse Museum's Sydney Observatory. And this is Space Time. And time now to take a brief look at some of the other stories making news in science this week with the Science Report. The World Meteorological Organisation has confirmed that 2024 was the warmest year on record. The findings, based on 6 international data sets, also showed that the past 10 years were the 10 warmest years on record, and that 2024 was likely the first calendar year with a global average or mean temperature of 1.55 degrees Celsius above the 1850 to 1900 average. The WMO's temperature assessment is based on multiple sources of data, including the European Centre for Medium-Range Weather Forecasting, the Japan Meteorological Agency, NASA, the United States National Oceanographic and Atmospheric Administration NOAA, the UK Met Office, the University of East Anglia, and Berkeley Earth. Meanwhile, a separate study published in the Journal of Advances in Atmospheric Sciences has found that ocean warming in 2024 also played a key role in the record high temperatures. The report found the ocean is the warmest it's ever been as recorded by humans, not only on the surface, but also down to a depth of 2,000 metres. The World Meteorological Organisation says China remains the world's biggest carbon dioxide polluter, producing a third of the total global output, amounting to more than 11.5 million tonnes annually. A new study has found that people who drink coffee in the mornings have a lower risk of dying from heart disease and a lower overall risk of dying from any cause compared to both people who drink coffee all day and those who don't drink coffee at all. A report in the European Heart Journal used survey data from over 40,000 US adults between 1999 and 2018 who were asked about all the food and drink they consumed on at least one day, including whether they drank coffee, how much of it they drank, and when they drank it. The information was then linked with records of deaths and causes of deaths over 9 to 10 years. The authors found that about 36% of people in the study were morning coffee drinkers, primarily drinking their cup of joe before midday. Another 16% of people drank coffee throughout the day, and 48% were non-coffee drinkers. Now, compared to people who didn't drink coffee, morning coffee drinkers were 16% less likely to die of any cause and 31% less likely to die of heart disease. Now, interestingly, there was no reduction in the risk for all-day coffee drinkers compared to non-coffee drinkers. Now, an accompanying editorial suggests that it's possible that coffee drinking in the afternoon and evenings disrupts the circadian rhythm that helps with sleep. That's due to its suppressing effect on melatonin, an important sleep-inducing mediator in the brain. New computer modelling suggests indoor vertical farming could help future-proofing food demands. The findings, reported in the journal Frontiers of Science, are based on studies using both sensors and experimentation to make this type of farming more efficient. Scientists created a model for testing smart lighting that aims to keep plants' ability to photosynthesize steady and constant over a full day, while still lowering electricity costs. The authors found that an optimization algorithm could cut electricity costs by 12% without compromising plants' carbon fixation by just varying light intensity. The study comes about because food production may well need to be increased by as much as 70% by 2050. The authors say vertical farming systems, therefore, could help provide intensive food production, while sensor systems could help reduce energy demands. Scientists have been investigating the genetics of a rare marsupial mole to find out more about one of Australia's most enigmatic species. Marsupial moles are small, just 14 to 18 centimetres long, and they're hard to find, with just 2 types known to exist, one living in the northwestern desert, the other in the central Australian desert. The researchers sequenced the genome of a female specimen from the South Australian Museum and found that these marsupials are most closely related to bandicoots and bilbies. The findings, reported in the journal Science Advances, show evidence that the marsupial mole's population was once far greater than what it is now. The population decline most likely driven by changes in climate rather than human intervention, although the animals may now often be falling prey to introduced species such as foxes. It's claimed that the Hexham heads, 2 allegedly Celtic stone heads found in a garden near Hadrian's Wall, are apparently cursed and could turn you into a werewolf. Or is it just that they simply look like werewolves? Or does it all really depend on what you want to believe? Tim Mendham from Australian Skeptics says people have been haunted for years by this paranormal holy grail, which just goes to show the power of suggestion.
story recently which cuts to the extreme. Hexam heads. Now, these were two small-sized Celtic stone heads, or presumably Celtic, about the size, each one about the size of a plum. So it's not big heads, not head-sized heads, it's sort of like little-sized heads, about the size of a plum, perhaps a large plum. Two of them were found in a garden near Hadrian's Wall in 1971. Caused a lot of fuss, all very exciting. BBC did a documentary about them. Some academics got involved and looked at them and said, oh yeah, someone did an analysis and said it's sandstone, etc. Ancient Celtic remnant, etc. But then people started sort of thinking, well, perhaps they're cursed.
Why would you come up with that conclusion just because you found some ancient archaeological artefacts?
Evidence. One of the neighbours next door said they saw some strange shapes, so perhaps that's because of the heads nearby. An academic took them home, very sober academic, normally, suddenly started seeing strange shapes, so, you know, a werewolf type shape wandering around the house where she had them, and her daughter had the same vision of werewolf type shapes wandering around the house and then disappearing.
Don't tell me they had mushroom soup the night before.
Yeah, I know, and they got rid of them and supposedly the werewolves went away.
Okay, now I thought you had to be bitten by a werewolf to become a werewolf.
That's a good question, actually. Never having been bitten by a werewolf, I'm not quite sure. Yes, I would have thought that, like zombies, you become a zombie if you're bitten by a zombie. If you're bitten by a vampire, you become a vampire. And if you get bitten by a werewolf, well, that's it for you. You know, you soon start sprouting hair and your face goes all weird.
What's the difference between a werewolf and a wolfman?
Yeah, it's another one. There were two different analyses done of these heads, trying to scrape a little bit off to see what sort of they're made of. One person said it's sandstone. The other one said it's cement. It doesn't look anything like sandstone. It seems to be sort of moulded cement with a bit of, you know, scraping away to give it a face. They're pretty rough faces. They're not exactly great sculpture, Michelangelo worthy. There's ancient Celtic. So one person came forward, whether it's reliable or not, named Desmond Craigie, who said that he made them in 1956 for his kids. Or his daughter anyway, to play with them. He said he actually made three, but one of them wasn't very good, so they threw it out. So they got buried in the backyard, and 15 years later, some other kids who, you know, moved into the house dug them up. Whether that's true or not, but what happened was that various people had a look at these heads. It went from hand to hand to researcher until finally someone actually lent them to a diviner, a water diviner, and they were never seen again. So BBC documentary came out in the mid-70s looking at these. Over the years, they lost half the audio, but they recently replayed them, which is why these Hexam heads have popped up again as an interest. They tried to fabricate, or someone just gave a voiceover of what the audio would have been for the first half of the documentary. Second half was okay. All the suggestions are it's unlikely to be cursed. They're not even certain that they're Celtic. They might be modern. Someone just carved them that looked like an ancient head. Certainly some other heads that appeared not long before the supposedly 1950s creation of these things. So someone might have seen pictures in the paper of these other heads that are found and said, I can do some of those. This fella used to work at a cement factory.
This is Luke. Yeah. Occam's razor. The simplest explanation is usually correct.
Yes, and that these were made. They might be Celtic. Very well might be Celtic. Who knows? This guy might have been, you know, having a joke himself. But they're not very good, and as for being cursed, there's absolutely no evidence of that at all, apart from one or two people having anecdotal stories, which, of course, if they believe in their curse, they'll see cursed type thing.
That's Tim Mendham from Australian Skeptics. That's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.